Very good morning one and all. Today we are going to discuss about our new topic in artificial neural network. So far we have studied a lot of learning rules, how the neurons are going to be update their weights, right? And there are various methods available in the neural network how the weights are going to be updated. Here I mentioned few of them. Hebbian rules, right? Hebbian rule is there, perceptron learning rule is there, delta rule is there, correlation, out star, well, right? These are the various type of learning rules are available, and I'm going to discuss one of them here, that is Widrow. Now before going with the particular learning rules, I want to discuss about few things related to the basic learning law. Learning rule means what? A learning process means what? Is a method to teach in mathematical logic. It improves the artificial neural network, performs apply these rules over the network. These rules update their weights and bias levels of the network when a network simulates in a specific environment. But it means that whenever you are going to update their rules, the bias values, automatically the model is going to be improve their accuracy in their efficiency. Applying learning rule is in an iterative process, and we can say that it's a iterative process too. Once we know that what is learning rule and how we are going to update it, so I told you that we are going to discuss about today Widrow-Hoff rules. We can call as delta learning rule in fact. So at the end of this session, each and everyone is going to understand that with the help of Widrow learning algorithm, we are going to make more strengthen the connections between the neurons in the neural network. What is the strength we have between the input, output and hidden layers? Once we know the outcome of this session, so now we can start our topic, Widrow-Hoff rule. Who introduced this? As the name suggests, Widrow and Hoff, there are two scientists. First one is here, Widrow. Second one is Marcian Hoff. These were the two scientists who given this rule in the year of 1960. And the same rule we can call as least mean square method in fact. Least mean square method, LMS method. This rule is the type of supervised learning process too. This rule is a learning process too. Here I mentioned clearly supervised learning method. And we know that what is the supervised learning? In machine learning subject we already discussed all these things. As I already told that basic concept, the base of this rule is the gradient descent approach. I told you that the gradient descent rule is nothing, it's a Widrow-Hoff rule or delta rule. What we are doing here in Widrow-Hoff rule, update the synaptic weights so as to minimize the net input to the output unit and the target values. Now this one is the working principle of Widrow-Hoff algorithm. We know about what is Widrow-Hoff algorithm, who given this concept. Now we are talking about the principle of Widrow-Hoff algorithm. The first step is initialization of the weight. Initially our human brain as well as the artificial brain is going to be assume random values. Once we initialize the values, then we are going with the iterative update process. There are 3 to 4 steps inside that. What are those? The first one, if you will see on the board, compute the predicted output by taking the dot product of the input features and the current weight. Now I can correlate this one. Here, according to the first rule, we know that what I mentioned there, the weight values and the input multiplications. How many inputs are there? With respect to that, the weight values we are going to multiply, and what is the net outcomes we are getting, that we are going to collect it from here. That is the first rule of this algorithm. That's what I mentioned here, taking the dot product of the input features and the current weight. Second, calculate the error between the predicted output and the true output. That's what I mentioned here. Second step of this algorithm. Now, and we know one thing, when we are going to talk about the neurons are going to work in two phases. The first one is the summation that we done, and second one is the activation function. Now what about this activation function? Activation function is nothing, y is equal to f of net. So whatever the function is there, whatever the values are there, as it is, we are going to get it in the output because of linear activation. As per the second rule of our Widrow-Hoff rule, they mention that error between the network output and the desired output. Whatever our model is going to be assumed, and whatever we are expecting, whatever the initial values we already finalized. Yes, this outcome we are expecting. So what is the formula for that? The error is equal to 1 by 2 the desired output minus expected output square. Error we calculated according to the second rule. Now the third one, update the weights by adding the learning rate. Now the time is whatever the error we received at the output level. So that error we are going to segregate, we are going with the help of backpropagation, we are going to segregate in with respect to all the weights values. And we are going to multiply with the learning rate. Why we are going with the learning rate? Learning rate means what is the efficiency of the model we have, and by default 1 we are going to assume it here. Now what is the formula here? This step we already calculated, this error we already calculated. Now using the chain rule or derivative with respect to the weights, this is the formula we are getting, d minus y into input. Once we know this small error, how much error is going to be contribute for each and every with respect to weights, we are going to update the final weights. What is the final weight values we have? So what is this? W equal to W minus alpha. Alpha is nothing, just now I told that learning rate. This one is nothing, learning rate. So this is our new updated weight. And in the last step, convergence, repeat step number 2 for multiple epochs or until convergence. So it means that whatever the 3 rules we have, these are the 3 fundamental steps that we are going to repeat it until unless we will not get the desired outcomes. This is the mathematical modeling of our algorithms. Previously I shown you the theoretical steps, and I correlated those theoretical steps with this mathematical modeling. Now I will move with the one example so that we can correlate each and every steps of this mathematical modeling, how the machine is going to be understood. This is the fundamental architecture of our learning rules. Here I assume that the various inputs, the first input I assumed it bias values or x naught you can say. Later on whatever the values we have x1, x2 up to m number of levels, and with respect to these inputs the weights are W1, W2 and Wn. Initially I told you that each and every neuron is going to be work in 2 stages. The first one is the summation. The first phase is this one, summation. So here we are doing with the summation. Summation means what? Whatever the inputs we have, that we are going to multiply with the weight values. Each and every weights with the input we are going to multiply and we are going to add it there. That is the meaning of summation here. So once you are getting the entire outcomes here, the function f I can write it here, and then I am applying the second phase here, activation function f of x. When you are applying this second phase, activation function, so accordingly you will get your output capital Y here. Might be this output is as per the desired output, or might be some variations are there. So you will get some error that you can check it from here. This is the desired output, this one is the expected output. So you can subtract it, and this is the formula whatever we have. In the last algorithm we have seen that 1 by 2 desired minus expected whole square. So if the error is there, that error, with the help of back propagations, with the help of these learning rules, we are going to see the changes, what is the new weight values. And once we know the new weight values, we can update all those weight values, and once again this process we will check it. Now we will come with the example so that everyone can understand how exactly this algorithm is working. Here I consider 4 inputs, x1, x2, x3 and x4. With respect to that, all of now we know there are 4 weight values, w1, w2, w3 and w4. Initially we mentioned that what are the w1 values? 1, minus 1, 0, 0.5, x1, 1, minus 2, 1.5, 0, x2, 1, minus 0.5, minus 2, minus 1.5, x3, 0, 1, minus 1 and 1.5. And they mention it also what is the desired output here, 1, minus 1 and 0. What is the activation function? This one is the summation only. And if I will talk about the second phase of this, that is nothing, activation function. That activation function they mention it here clearly, y is equal to f of net equal to net. And we assumed learning rate alpha is equal to 1. Maximum efficiency, we are assuming that yes, with the maximum efficiency our module will work. Now we will go with the first iteration here, iteration 1. According to the iteration 1, what is our desired output here? 1. That's what I highlighted also there. As per the algorithm, our first step is we have to calculate what is the net output here, all the weight values and input values with respect to x1. And what is the weight values are there? 1, minus 1, 0 and 0.5. That's what I mentioned, all these weight values here. And what is your x1 input? 1, minus 2, 1.5 and 0. If you will multiply, this 1 is to 1, 1. This minus 1 is to minus 2. This minus 1 is to minus 2 is plus 2. So here I can write it plus 2. 0 into 1.5 plus 0. And minus 0.5 into 0 is again 0. So overall sum is 3. This is the first phase of that. What is the summation? Now when you are applying the activation function, we know that we are going to get it the same value. So that's why here one more time I mention here capital Y is equal to 3. So finally we got it y equal to 3. Now we are going to check it, what is the error exactly we have, how we are going to update the values. The alpha learning rate and d minus y desired output minus expected output, and we know that 1 is our desired output and 3 is our module output, so 1 minus 3. And what we are going to do, multiplying with the x1 input, so that you will get the new weight values for the next level. So when you are going to multiply with the input, what is this? 1 minus 3 is nothing, minus 2. So minus 2, you just multiply with this input, so you will get it minus 2, then plus 4, then minus 3 and 0. These are the new updates, new weight values for the next iterations. Now when you are going to calculate the W2, so what is the formula? We know that W1 plus delta W1. What is W1? That we know that 1 minus 1 0, 0.5, That's what I mentioned. And delta W1 just now we calculated here, minus 2, 4, minus 3 and 0. When you are going to add both of them, if you will see 1 plus minus 2 is nothing, minus 1. In the next level, minus 1 plus 4 is 3, 0 minus 3 and 0.5. This is the complete one process. Finally, you got it, the new weight values for your next input, that is nothing, x2. So one more level, I will go with the iteration so that all of you can understand. Yes, I am going to repeat the same steps. Now, according to the input second, here I highlighted also the input x2. What are the inputs? 1, 0.5, minus 2, minus 1.5. And what is my desired output? Minus 1. And just now we calculated the weights also. So, with respect to those, now here you will see my new weight are minus 1, 3, minus 3 and 0.5. As it is, the same I am going to use for my next step here. Minus 1, 3, minus 3 and 0.5. And what is my x2 inputs? That's what I mentioned. 1, minus 0.5, minus 2, minus 1.5. If you will again multiply these factor minus 1 into 1, you will get it minus 1. And 3 into minus 0.5, you will get minus 1.5. Minus 3 into minus 2 plus 6, you will get 0.5 into 1.5. If you will calculate, you will get 0.75 approximately. And if you will add all these values, you will get it here, 2.75. When you will apply the function, activation function, again you will get the same value. That's why I am writing here 2 times 2.75. Once you know this output, what we are doing, we are going to calculate that small delta W. Alpha learning rate, initially only we assumed that by default 1. What is it, the D2? D2 is nothing, desired output minus 1. This is not D square, this is D2, only representation is different. So minus 1. What about your model outcomes? 2.75, so minus 2.75. And what about your x2 value? X2 we know that the same, 1, 0.5, minus 2, 1.5. That's what we are writing here. When you will multiply these values, what is these outcomes? Minus 1, minus 2.75, minus 3.75. And this minus 3.75, when you will multiply with this input, minus 3.75, 1.875, 7.5, 1.62. And when you are going to calculate the new weights, you know that what is the W2? We calculated in the previous step. And delta W just now we calculated, both we are going to add it. So what is the new weight values that I am going to write it here? Minus 1, minus 3.75 is nothing, minus 4.75. 3 plus 1.875 is nothing, 4.875. And what about the next minus 3 plus 7.5? It's nothing, 4.5. And 5.62 plus 0.5 is nothing, 6.12. These are the weight values, and the same steps we will repeat 2 more times, and finally whatever the weights are going to become, those are the accurate weight for this entire module. Initially we assumed something, but at last, according to this entire algorithm, whatever we are getting, that we are going to update it. So this is all about the Hoff algorithms. Thank you friends. Thanks a lot.